Translating from English to logic. You're going to see this a lot in the book. I can't stress how important the domain or the universe that it gives you is. It makes a dramatic difference between the two. So in each example that you're going to see, the universes are different. So in this one, it's all students in the class, and this universe is all people, and you're going to see some other exercises here where they are different. Pay particular attention to that because, frankly, it changes the answers, well, rather critically. So careful on that. So in our first example, we have every student in this class will have taken the course. So let's break this down. First, we're actually going to check out what the function is going to be, that X has taken a course in Java. And then we're given the every part, so we know that we're going to use our universal quantifier when it comes to this one. So we have A of JX when it comes to the overall thing. But again, notice our universe is all students in the class. So just a heads up. Now, it's very different when it's all people. This time we are going to have a function that's going to be for the students that are in the class, and then they have taken Java, and again, still looking for every. So notice this time, students are actually part of the function, and that's why we have this crazy result, which is very different than the other one, because this one, it was all people, and not all people are students. So we had to specify that it was going to be a student, and then if it was a student, then they had taken Java, and that's basically what I'm just reading off here from here. So notice, very different answer, and we even have the implication because, again, we're looking for a specific student. That's the crazy part. Wait for example 2. All right, for number 2, we have some students in this class have taken a course in Java. If our universe is all students in this class, our universe is rather small already, then all I need, we already know what our function is because, frankly, we had it from before, and we're using our existential quantifier on this one, then we're going to have, well, e of x or the existential of our function j of x of those in the class. Now, again, notice the big change here that all people are being selected for this. So now we have to add that student in the class again because we have to define frankly, our input for, hey, needs to match students in the class first, and then to see if they're in the Java class itself. But here's the interesting part here. For this answer, I need really this first one that's being highlighted right now. So I need the if there exists a student and, there's the and, they have taken Java. Then we can have a true response for this. Now, some of you might have thought you were going to have that arrow in there again, but here's the bad part. This handcuffs to say that every student that's here has had Java. We're not looking for every student. We're really looking for some in this example. So that hinders us quite a bit. So just be careful with that on that particular question. Example number 3 is really basically the same idea. Some students in the class have visited Mexico. So again, you have there exists a student and, by the way, student in this class. I shouldn't just say student, so forgive me. I might have done that in the previous one. There's a student in this class and they have visited Mexico. So we're defining our input a little bit more using that first function of f of x. We're just doing an and from that. So they were in the class and they visited Mexico. Then we had a satisfaction of this particular propositional function. Now notice how this changes, and this time there's 2 changes for number 4. This time we're looking for every. So now you kind of know why this one we can get away with that. And have visited Canada or Mexico. So that's the crazy part. So we looked at the previous one that had all. We're going to be looking for all, or all students have either, if it's a student in the class, they have visited Mexico or Canada for that problem. Finally, your exercise, and this is a big one. You need to take your time on it, make sure you're good to go with it and all that good stuff here. So I'm going to leave you to this here, but again, notice I'm giving you a certain data set when it comes to our overall universe. And then we have our different functions. And then each one of those up to, I think, 10, 9 actually. 9, 10, 11 are on their own really when it comes to this. So they are different problems. So just a heads up on that. Hit pause. This is going to take a while, and this is going to show up on homeworks and tests and stuff like that. So please make sure you take your time on this, and I'll go over and answer here in a little while. But get to work, pause for a while, and we'll see you in a bit. So here are your answers for all of the different ones, except for 10 and 11. I have them linked to a video that you'll need to click from the notes and then go from there, and they explain it in much more detail and better detail than I would have anyway. So, but here's your different answers. Everything is a Flegel. Nothing, notice the negative or the negation here that we have in here. All Flegels, as soon as we see that all or everything, and this is are snurred. So notice these are two related different in functions. So as soon as you see that, that's where you think of the arrow or the implication coming into play here. No snurred is a thingamabob. So I'll have you go through each one. Please ask if there's any questions, but really honestly, the first 8 I'm going to say are not too bad on getting things done here. But then after that, let me know if there's something, and I'll go over it with you. I have no problems with that. So let me know.